This is Dr. Holt. I want to go over 3 of the problems from the summation packet. This is 4-12. Here you have a beam. You want to determine the range for the distance A being right here, for which the reaction at B does not exceed 100 pounds downward or 200 pounds upward. Again, the first thing you should do is draw yourself your free body diagram. I'll draw it as just a figure like this. We're going to first thing work it with the 100 pound going down, so I'll show the 100 coming down this way here. And we'll label that as 100 pound. We have a 50 pound coming down here. Right there. We're going to take our moment around D, which is this point right here, so we'll put that right about here. Alright, and that's going to be D. Now what I'm going to recommend first is that you move these. I'm going to move this to put this one here right on top of it to start out with, and I'll explain why. So I'm going to put this here, and then I'm going to put the other one over here. Don't quite look right. Okay. I'm going to label this as 300 here. 300 here. I'm going to make this to be 6. We know this distance here is going to be 4, and we know the distance from here to here is going to be 4 plus 12, that's 16. Okay, and the reason I'm going to do that is I want to find out, to make sure that both of these 300 either need to be at this location or further to the left for this to be 100. Right now I don't know. I just want to verify that first. So I'm going to sum the moments around that point is what? D. And when I do that, I will get minus 100 times 16. Oops, make it 16. Sorry about that. 100 times 16 minus the 50 times 4 plus the 300 times 6. And we're going to see, and I don't know if that's equal to 0, but we'll find out what that's equal to. This gives me minus 1600 here, minus 200 plus 1800. Now I got lucky in that I got this to be 0. Okay, if it wasn't 0, then I would have to keep shifting this until everything balanced. And what I would do, I'd add another x. And when I work on the other side, you'll understand what I'm talking about. So right now I already have one of the A values. So if these line up, if I moved all this over here, then the distance between here and here would be 6. We know from this rotational point to here is 8. So if I take 8 minus 6, that gives me an A value of 2. So we know right now that A has got to be larger than equal to 2. Alright, I'm going to go ahead and steal this free body diagram. Grab this, because I don't want to draw it again. Edit, copy. I'll drop it down here. Edit, paste. Move it into place. Now I'm going to do something similar. I'm going to take these guys, I'm going to slide them over here, but now I'm going to line it up right here. And I'm going to see what's going to happen over here. Now this load, I think it said 200 pounds upward. So I'm going to rotate this one back up like this. I'll bring this up here. I'm going to change this. Yeah, we'll get rid of that. I'm going to change that to 200. Okay. Now I'll go ahead and take out the A. I don't need that right now. I'm going to run the moment again at D and just see whether or not I need to shift these to the right or even possibly back to the left. I don't know right now. So if I take the moment at D, I will get 300, that'll be negative, times 6 minus 50 times 4 plus 200 times 16. That gives me minus 1800 minus 200 plus 3200. That gives me minus 2000 plus 3200 gives me a net moment of 1200, which means right now I got too much going this way. So that tells me immediately that I need to shift these to the right. I need to shift them more to the right to balance out, to get another 1200. So I'll run it again. I'll show you what I'm going to do here. Grab all this again. We'll clone it, edit, copy. Come down here, edit, paste. Come down here. Okay, now I'm going to grab these. I'm going to keep sliding them a little bit. I'm going to slide them in this direction here, like this. Now, I'm just going to make this distance to become x, just some variable that I don't know. So I'll set this up to be a value of x here. Now we'll run the moment again. I'm going to sum the moment a d, and this time we're going to set it equal to 0. It has to balance out. So when I do that, I would have minus x times 300 minus 300 times x plus 6, meaning the distance, this force times this distance would be x plus 6. Okay. And then set that equal, and then, plus the 200 times 16 must equal to 0. When I do that, let's run the math. That gives me minus 300x minus 300x minus 1800. And then, oh, I forgot one. I'm sorry, I forgot the 50 plus 4. Come back up. Sorry. Forgot the 50, so let's do that too. Minus 50 times 4 is equal to 0. Okay, now we'll add this back in, so that gives me minus a 200, and now plus the 3200 is equal to 0. We do that, that gives me minus 600x. We get that, that's minus 2000, that would give me what, another 1200, plus 1200 is equal to 0. Move this other side, and then when that give me x is equal to negative 1200 divided by negative 600, which gives me a value of 2. So that tells me that this distance here is 2. We will erase that right there. We'll make that to be 2. And now we know that this distance originally, according to the beam, was 8. And A is the distance from here to where that occurs. So all I have to do is take 8 plus a 2, that gives me 10. So A has to be less than or equal to 10. And we already earlier found out A here was greater than or equal to 2. And that would be my correct answer. That's the variation I could get for A to keep everything in equilibrium. All right, let's go to the second problem. This is really a nice problem. It's a challenging problem. I'm going to kind of show you something a little bit unique to do this. I'm going to create another axis system. I think it makes the problem much easier to solve. So what I'm going to do is I'm going to draw an axis system right through the middle of this. And I'll show you what I'm doing. And I'll color code this so you can see it. So to do this problem here, I'm going to create an axis system right through the middle, and I'm going to move it down into where the B is. So right there. I'll make that line up better. Alright, and I will, let's see, we'll color code that, make it a different color, and actually I'll dash it or something so you can see it. Okay, there's an axis there. I'm going to create another axis, the vertical part going back up this way. It's going to go right through the middle of that, like that. Again, I'll make that red. And you'll find out why I'm doing this, because it's going to make it a lot easier to understand, I believe. There's a little bit of trigonometry you have to do here to get everything located, but I'm going to go ahead and show the vectors. Let me get a vector here. Draw this vector coming down. I'm going to draw this vector coming down. Again, I'm going to color code those just because it blends in. We'll make those to be blue. And make this one to be blue. Alright, now we know this angle here is going to be 35 degrees. do that in blue too. This angle here is going to be 35 degrees because it's given right here. All right, so I'm going to break these two in components and base upon these new axis systems. So the components of this would be, I'd have a vector coming down like this, and the other one would be coming back over like this. Again, I'll color code those. And let's do purple. And make that purple. Okay, we'll do the same thing here. I'm going to just clone these up here. Hopefully I can grab that. That doesn't work. Bear with me, Sam. I'm going to lock this so it doesn't move around. Now let's see if I can do this again. Grab this guy. Edit clone. If it doesn't work this time, I'll just redraw the stupid thing. Grab this, move it into place here. Now it's going to work. Take this guy, we'll clone it. Okay, again, I'm going to move it back into place. They're the new components in this orientation. Now, the hard part is to understand how to get these angles. Now, if this is 35 degrees, I could go ahead and, I'll show you from a geometry standpoint, draw this parallel to the red. Draw this horizontal here. So, let's think about this. We know this angle here is 90 degrees. If this angle here is 35 degrees, then 90 minus 35, that gives me 55 here. If this is 55 here, this is going to be 35 here. This makes this angle 55 here. So I'm just doing, just subtracting the angles to get this. Okay. So I know this angle right here, again, is going to be 55 degrees. I know this angle here is going to be 55 degrees. All right, so now what I'm ready to do, I'm ready to nail this problem. We're going to take a moment around B. So if I take the moment around B and set it equal to 0, then I'm going to take what's the mass of these? 40. I'm going to take 40 times 9.8. When I do that, that gives me this guy. I'm going to break it into components. I'm going to take it times the cosine of 55. That's 55 degrees. Times the vertical, which is 300. So this right here is this component times this vertical distance. Now it's causing a moment around B to go this way here, so I'll leave that positive. Now this component here is going to make it go back the other way, so we're going to minus 40 times 9.8 times the sine of 55 degrees times 80, because this distance here is 80. So from here to here, the distance from the center of this to this vector is going to be 80. So that's it. We've done everything we can. Again, this one's going back this way. Now we do the same thing for the other one. Now you notice this component here will be the same as this, and the distance from here, perpendicular to this vector, is still 300. So we'll just continue. We'll do plus, and that would give me the plus, and that would give me 40 times 9.8 times the cosine of 55 degrees times the distance of 300. Alright, now the only thing we got left to do is to get this one. Again, that's going to cause a negative moment, so it'll be negative 40 times 9.8 times the sine of 55 degrees. Now the distance from here perpendicular to B is going to be 350 plus 80. That's going to give me a value of what? 430. Okay? Now plus P. Now P is a vertical one. I need this horizontal distance between B and P. The distance here, and I don't think this will be confusing, if the angle here is 35 degrees, all I have to do is take 80 plus 350, that's 430, plus 500, that's 900 from here up to here. I take the 900, make sure I did that right, sorry, 80 plus, that's 350, that's 430, 930, sorry. Take 930 times the cosine of 35. And again, all that has to equal 0. And again, just if there's any confusion here, I want to make sure you understand exactly why I'm doing 930 times the cosine of 35. I'm looking for this distance here. This is my vector. I need the distance from there to there. If this distance from here to here is the summation of these, if I multiply that distance times the cosine of 35 degrees, which this angle would also be 35 degrees, I get this distance here. That's what that is. If you solve now for P, you will find out that P, the force going up, is going to be 37.88 newtons. All right. Now here you have two wheels. I want to find out what the summation of the forces are going to be on the wheels. All you have to do here is just take the summation of forces in the y is equal to 0. Now the y here is not this y here. I should have noted when I did this problem here, when I was doing this, the moments, I was based upon the new axis system. When I'm here, I'm just going to take the vertical forces. So I'm going to do minus 40 times 9.8 minus 40 times 9.8. I've got two forces coming down plus the P coming up, 37.88 plus FBY is equal to 0. I'm going to solve for FBY. FBY is going to equal to 746.12 newtons going up. Now since you have two wheels, just divide that by 2, so FBY for each wheel would equal to half of that, and that's going to give you a value of 373.06 newtons. All right, so that problem, if you tilt the axis, you create a new axis system, it becomes much, much easier. It can be done by keeping it vertically, but keeping everything vertical, but I think it's more complex. If you create a new axis system, the problem's not that difficult. All right, this is 417, and you know, in reality, this problem isn't as difficult as it looks. If you draw yourself a good free body diagram, I think you'll see that. So I'll draw this over here. I'll draw this down here. This part here will be C right here. So I have a force coming down here. I have a force coming here. I'm going to assume that this force would go up and this force would go this way. So this will be FCY. This will be FCX. This will be P. We know AB is 200 here. All right. Now we know this distance here is going to be 15, and we know this length here is 7, and we know this angle here is 60 degrees. All right. So again, all you got to do is take a moment around this point, set it equal to 0. If I sum the moments at C, I will get P times 15. Again, that's positive because it's making it rotate this way. Here, I'm going to do minus. This is making it rotate back this way, this 200. Like this, that's going to be negative 200. Now, this isn't that difficult. All you need really is a perpendicular distance. So isn't that just 7 times the sine of 60 degrees is equal to 0? And that's really it. You just solve for P. P is going to be 80.83 pounds. Okay, if I called one of those newtons, I apologize. Everything's in terms of pounds. Now you're back to this. Summation of forces in the x is equal to 0. The only forces you have would be here and here. So minus 200 plus FCX is equal to 0. FCX must equal 200 pounds going to the right. Summation of forces in the y is equal to 0. I have the P, which we said was coming down, minus 80.83 plus FCY is equal to 0. FCY is equal to 80.83 going up. And again, that would be pounds. Now to get the actual force at C, all you have to do is say FC is equal to, using Pythagorean theorem, is equal to the square root of 200 squared plus 80.83 squared. Take the square root of that. That's going to give you a value of 215.7 pounds. Okay, and then if you want, you can find the angle. And again, I always recommend that you draw the direction they're going to go. So you get the angle. Again, this value here would be 80.83. This value here would be 200. Our vector is going off this direction here. All we have to do is find this angle theta here. So I would take the inverse tangent of 80.83 divided by 200, and when you do that, theta would equal to 22 degrees. Okay, the correct way to present this is to do this. F of C is equal to 215.7 pounds. Show my vector going up like this. Go ahead and show this as a line and set that equal to 22 degrees. And that's your answer. All right, I hope this video was useful to you guys. It shows you how to solve 3 of the most difficult problems. All right, best of luck.